All right, so the next part of the notes here, we are trying to determine if it's a permutation or a combination. So we're trying to determine, does order matter or does order not matter? And then we're going to go ahead and we're going to evaluate. So when we're looking for if order matters or not, there's some words that are really going to help us. In the first example here, a subway car has 8 empty seats. At one stop, 5 people enter the car and no one gets off. How many ways can the 5 people arrange themselves in the 8 empty seats? So the word that sticks out to me right here is arrange. This word means permutation. It means order matters. We're arranging them in an order. First, second, third, whatever you want to call it, but we're arranging them in a specific order. So that's a permutation. So I have 8 total, and I'm going to pick 5 of them. So remember, permutation tells me I have that P there. So from here, I can go ahead and I can do 8 factorial divided by 8 minus 5 factorial. This is my permutation equation. There is no extra r here, so they're different equations. Make sure you're using the right one. So when I do this, I get 8 factorial divided by 3 factorial. Plug that into my calculator and keep going, and I get 6,720 different arrangements. So my next one here, a history test lists the names of 5 presidents, and each student is to choose 2 of them to compare in an essay. How many different pairings are there? Remember when we talked about combinations, this word pairings is really important for us. That means it's a combination. So I know that I'm going to have 5 total, and I'm going to choose 2 of them because it's a pairing, so I have 2 of them. So since it's a combination, we are choosing. So my formula for this is I do n factorial divided by n minus r factorial times my r factorial. I'm going to simplify, and I get 3 factorial, 2 factorial. So when I go ahead and I put this all out, I end up getting 10 pairs that I can make. Next example here, I have a survey that asks people to rank basketball, baseball, tennis, soccer, and football according to how much they enjoy watching each sport. How many possible responses are there? Well, when I'm talking about ranking, I'm talking about a first, a second, and a third. First, second, third, those tell me that order is extremely important. So permutation it is. So I'd figure out how many total I have. I have 1, 2, 3, 4, 5. And I'm going to pick, when I'm ranking them, I'm ranking all 5 of them. So I'm actually going to pick 5. So when I do this, since it's a permutation, I'm doing 5 factorial divided by 5 minus 5 factorial. So I end up with 5 factorial divided by 0 factorial. Now you would think 0 factorial would be 0, but plug it into your calculator and surprise, surprise, you get a 1 down there. So you have 5 times 4 times 3 times 2 times 1, all divided by 1, which is going to go ahead and give you 120 responses. So our next one here, there are 20 students in the speech club. 3 of these students will be chosen to represent the school at a regional competition. How many different groups of 3 students can be chosen? Remember again from our notes earlier, groups tells me it's a combination. So I have my total of 20, and I'm going to choose 3 of them for this competition. So I have 20 factorial on the top, divided by 20 minus 3 factorial times my r factorial. So I get 20 factorial divided by 17 factorial, 3 factorial. Go ahead and do that work there. Remember, the 17 can be canceled out with the 17, 16, 15 on down to 1 on the bottom or on the top. So when I did that, I got 1,140 groups. Last example here, how many ways can the letters in the word combination be arranged? Well, again, arranged is really important. That tells me order matters, so we're looking at a permutation here. But this isn't going to be our normal permutation. Since it's a permutation, remember, when we have letters that repeat, we have to do the total factorial divided by the repeats factorials. So total in here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters, so 11 factorial. And I have a couple of letters that repeat. I have the O's that repeat, so I have 2 of those, so I get 2 factorial there. I have the N's that repeat, So I have 2 of those, so I have 2 factorial there. And I have the i's that repeat. So I have 2 of those, so I have another 2 factorial there. So when we do this, remember 11 factorial is 11, 10, 9, 8, all the way down to 1. And then 2, 1, 2, 1, 2, 1 on the bottom, because you have to write out each of those different factorials. So 9, 8, 7, 6, 5, 4, 3, 2, 1. 2 times 1, 2 times 1, 2 times 1. Plug that all into your calculator, get your answer. You should have 4,989,600 different ways that we can arrange the word combination. So the last thing you have now is your practice. If you have any questions, please come chat.